Hello everyone. In this video, I am going to explain 80386 microprocessor flags. So 80386 is 32-bit microprocessor. We have already learned the architecture of 80386. So there is a EFLAG register. The register is known as EFLAGs register. So there are various flags, and flags are divided into different categories. So what are the categories? There is status flags, there are control flags, and there are system flags. So status flags are represented by letter S. So you can see here this parity flag, auxiliary carry flag, zero flag, sign flag, overflow flag. All these flags are status flags. Then C indicates control flag. So wherever there is C, you can see that this is direction flag is control flag, and X indicates system flag. So let's see one by one. So let's start with direction flag, which is a control flag. Now, what this flag does? Where is direction flag? So direction flag is here. This flag is specifically used in string instructions. String instruction means when the data is saved sequentially in a memory, then we call it as it is a string of data, or you can call it as a block of data. So let's assume that this is memory, and there are data stored in this memory locations. So this is a bottom location, and this is top location of memory. And there is some current instruction which is currently we are accessing. So what direction flag does? This flag is specifically used in string instructions. And what happens if direction flag is 0? Suppose this flag is reset, that means it is 0. Then what happens if direction flag is 0? The access the string data from lower memory location towards higher memory location. That means suppose currently the processor has accessed this particular location, the next data it will access from higher location. Higher means in this direction. In this direction. That means currently suppose processor access this location of data, then next it has to access next location data, and then next, and then next, and then next. If direction flag is 0, that means direction of data available, it indicates the direction of data available. That means data is available in this direction. On the other hand, if direction flag is 1, that means if it is set to 1, then what happens? Then it accesses the string data from higher memory location towards lower memory locations. That means now it indicates that data is available in the lower memory location. So suppose currently it has accessed this particular data, then it will access the next data from previous location, then previous, and then previous memory location. So what direction flag does? It decides the direction of data access. Or in short, we can say that it tells us where the data is available, whether the data is available after the current data access or before the data that we have currently accessed. Sorry. The next flag is trap flag. So you can see here, this is your trap flag. Trap flag is system flag. So direction flag was control flag, and trap flag is system flag. So what trap flag does? When trap flag is set, that means when it is 1. When trap flag is 1, that means when it is set to 1. Then 80386 generates an exception 1 trap after the next instruction is executed. What is the meaning of this statement? Suppose there is a program and there is a sequence of instruction that 80386 is executing. In that case, if trap flag is set to 1, then we can see the status of different registers or result after execution of every instruction. What it means, if trap flag is set to 1, then we can check the status of registers after execution of every instruction. But if trap flag is 0, if it is not set, then we can check the status of registers or result only after execution of entire program. So this is a meaning of trap flag. Now next is interrupt enable flag. That means IF flag. So as name suggests, it is related to interrupts. What is interrupt? When any device, when any external device This is 80386. When any external device want to get some program executed from 80386, then this device will send interrupt to this 80386 microprocessor. This interrupt concept we had already learned in 8086 in detail. Okay, now suppose let us assume that this is 80386, this is external device, and this device wants execution of some program. So this device will send interrupt to 80386. Now, if this interrupt flag is 1, if this interrupt flag is 1, that means when IOPL is set, it allows recognition of external interrupt signaled on INTR pin. So 80386 has INTR pin, and if IOPL is set to 1, and if this device sends the interrupt, then 80386 will recognize that interrupt, means it will accept the interrupt. So it will accept the interrupt, and then it will go here, it will execute this program and will come back to its original program. But if this flag is not set, that means if interrupt flag is 0. So if interrupt flag is 0, and in that case, if this external device sends interrupt to 80386, it will not accept that interrupt and it will not execute its program. Now next flag is IOPL flag. The long form of IOPL flag is input output. Sorry, PL stands for privileged level. So privileged level is nothing but a priority level. So what happens? Where is this IOPL? So this is a position of IOPL flag. So what is privilege level in 8086? A privilege level in 86 instruction set, what it does, it controls the access of program currently running on the processor to resources such as memory regions, input output ports, special instructions. So there in 80386 there are various instructions. Some instructions are for handling memory regions, some instructions are for accessing input output ports, some instructions are special instructions. So there are various category of instructions. So this various category of instruction will be allotted some privilege level. So there are 4 privilege levels ranging from 0, which is most privileged, to 3, which is least privileged. That means privilege levels can be assigned from 0 to 3. So 0 has the highest privilege level and 3 has the lowest privilege level. That means 0 has the highest priority, you can say, and 3 has the lowest priority. You can see in this diagram it is shown symbolically here. So privilege level is the most privileged level, then comes privilege level 1, then comes 2, and then comes 3. Now suppose this is a microprocessor and its current program instructions. So this microprocessor is executing some current program and there are a sequence of instructions. There are some memory related instructions, so this will be having some privilege level. There are input output related instruction, it will have some privilege level, and there are some special instruction, everything will have its own privilege level. So let's see how it works. Now you can see here, suppose let's assume that this current program instruction has privilege level 3 and this processor is executing these instructions. So since it is currently executing this instruction, it is said that it is current privilege level. So its current privilege level is 3. Let's assume that the memory related instructions has privilege level 1, input output related instructions has privilege level 3, and special instructions has privilege level again. It can be anything, it can be 0, 1 or 2 or 3. So what happens? The IOPL field in the EFLAG register defines the right to use input output related instruction because it is input output privilege level. So it is related to input output port related instructions only. What happens? This mechanism operates only in protected mode. That means this IOPL will work only when 80386 is operating in protected mode. Protected mode means when it behaves like itself. The processor uses 2 bits of flag register to store input output privilege level. So here it uses bit number 12 and bit number 13 of this EFLAG register to store privilege level of input output related instructions. What are input output related instructions? So there is in, INS, out, outs. These are input output instructions. Suppose let's assume that IOPL has privilege level 3. input output instructions has privilege level 3. For storing, because here IOPL is 1-1. 1-1 means it has assigned EFLAG register or flag has assigned privilege level 3 to these instructions. Now in this, microprocessor current program instruction has this current privilege level is 3. So it can access this instruction because their privilege level is same. Even if this privilege level is 2, then also it can access this program because 2 is the higher privilege level. So higher privilege level program can access this instruction. Even if current privilege level is 1, then also it can access this 3. That means if its current privilege level is 3, it cannot access this. But it can access this because it is on same privilege level. So what happens? This works like this. I will show you. Let me erase this. Now see here. If program has privilege level 0, privilege level means highest privilege level, then it can access the instructions with all privilege level. That means PL0, PL1, PL2 and PL3. If program with PL1, it can access PL1, PL2 and PL3, but this program cannot access the instructions with privilege level 0 because 0 has higher priority. 0 can be accessed only by 0. If program with privilege level 3, it can access instruction with privilege level 3 and not 2 or 1. So this is how this privilege level works. So what for this IOPL is used? IOPL is used to assign privilege level to input output related instructions. That means these instructions. Now next flag is NT. NT stands for nested task and it is a system flag. So you can see here this is NT flag. What NT flag is? What NT flag does? It is a nested task. That means it is used in case of nested loops. This flag applies to protected mode. Again, it is applicable only when 80386 works in protected mode or operates in protected mode. NT is set. That means it is 1. What for it is set? To indicate that execution of the task is nested. That means there are nested loops within another task, and it indicates that current nested task has a valid backlink to the previous task. What is the meaning of it is having valid backlink? Let's assume that there is one program. The program consists of instruction 1, instruction 2, and there is some call instruction which is calling another address. That means it is calling a program stored at this particular location, and then there is instruction 4 and instruction 5. So what happens? Processor will execute this instruction, this instruction and this instruction. Then it understands that it has to go to some other address, and then it will go to this address. So this is address number 1, which is stored in the same memory, and their separate program is stored. At address 1, there is a different program is stored. Again, there is instruction number 1, but this instruction and this instruction need not to be same. So there is another program stored, and again in this program there is one call instruction which is calling another address, that is program stored at address 2. So it will switch over from this location to this location. That means it will execute instruction 1, instruction 2 and this call. Then it will the control will get transferred to this new address. It will execute this instruction and this instruction, and then it will stop execution of this program, and then it will switch over to next address. It will execute this instruction and this instruction. And there is no call, actually this is by mistake, it had remained. So it will complete the execution of this instruction. So first it will execute this all instruction, and then at the end of this program there is return. So after executing return, it will go back to previous program. Then it will complete the execution of remaining instructions of program stored at address 1. After that, again it will go back to first program, and it will complete the execution of instruction 4 and instruction 5. So like this, you can see here there is a valid backlink. This is known as nested task has a valid backlink. That means if NT is 1, that indicates that there is a valid backlink. Same is applicable for interrupts. Now next flag is resume flag. Resume flag, it is denoted by RF. You can see here, this is resume flag. What resume flag is used for? The flag is used when debug register breakpoint. Used with debug register breakpoints. What is the meaning of this? This flag is checked at the starting of every instruction cycle. So what is instruction cycle? The time required for execution of one instruction is known as instruction cycle. So before execution of every instruction, first it will check this flag. The flag is checked at the starting of every instruction cycle. And if this flag is set, then debug fault is ignored. That means if there is any debug fault in that instruction execution, then it will be ignored during the instruction cycle. And the RF is automatically reset after successful execution of that instruction. That means it will reset after execution of every instruction except IRET and POP-F instruction. Next flag is VM flag. That is, V stands for virtual mode flag. Again, it is a system flag. So this is VM flag. What for VM flag is used? It is virtual 8086 mode flag, bit number 17. The VM bit provides virtual 8086 within the protected mode. Suppose let's assume that 80386 is running in protected mode. Protected mode means it is working like 80386 microprocessor. Protected mode means 80386 behaves like 80386 processor. And in between, if this flag is set, then while 80386 is in protected mode, the 80386 will switch to virtual 8086 mode. That means it will start behaving like 8086. When this flag is 1, 80386 can execute 8086 instruction or 8086 program. So handling segment loads as 8086 does, and segment will also be operated like the way 8086 does. That is known as virtual 8086 mode. That means whenever 80386 is in virtual 8086 mode, then this flag is 1. Sorry. Last is nothing but status flag. Now status flag we learn in 8086 microprocessor in detail. Here I am going to give only brief. If you want to learn in detail, then you go to 8086 flags and find out what are status flag. Now what are status flag? As the name suggests, it shows us the status of 80386. That means after every arithmetic and logical operation, according to the result, the status of 80386 will vary. So how it works? Let's start with sign flag. So here it is sign flag. This is your sign flag. What sign flag does? After arithmetic and logical operation, if this bit is 1, it indicates that the result operation is negative. That means most significant bit of that operation is 1. Or if this is 0, it indicates that the result of arithmetic and logical operation is positive, or most significant bit of the operation is 0. Next flag is 0 flag. What happens after arithmetic and logical operation if result is 0? If result of arithmetic operation is 0, all zeros, then 0 flag will set to 1, otherwise it is 0. Next is auxiliary carry flag. What auxiliary carry flags does? It will set when there is a borrow or carry from nibble. Nibble means nibble is combination of 4 bits. Whenever carry generates from this 4th bit to 5th bit, then the auxiliary carry flag will set to 1. Otherwise, if there is no carry from 4th bit to 5th bit, then this flag is 0. The next flag is parity flag. What is parity flag? After arithmetic or logical operation, if result holds even number of ones, you count the number of ones, and if that ones are even, then parity flag will set to 1. Otherwise, it is 0. That means if ones are odd, then parity flag is 0. And last is carry flag. What carry flag is? Carry flag, if carry generates from the most significant bit after arithmetic and logical operation, then carry flag will set to 1, otherwise it is 0. So carry flag is set if carry or borrow generates from higher order bits and cleared otherwise. And then there is overflow flag. What overflow flag does? Overflow flag is set if result is too large, a positive number, or too small, a negative number. That means if you add two negative numbers and if you get a positive result, then overflow flag will set to 1. Otherwise, not. Or if you add one negative number with the positive number, and if your result is positive, then whenever there is a wrong result, the overflow flag will set to 1. So it was about status flag. So I hope you understood all the flags, how it works in 80386. Thank you very much. Thanks for watching.